very good evening and welcome to Vedantu Daily Sessions. As you all know, we are talking about chapter number 2 and we have already completed chapter number 1. You remember, right? And in chapter number 1, we have done 5 videos with all important topics. Chapter number 2, this is the second video, right? So now, what are we going to do in this second video of Is Matter Around Us Pure? As you know, we'll be talking about all important topics. First video we spoke about what is purity, what is impurity, which substances are pure and which ones are impure. In today's video, we're going to talk about one super important, rather than saying topic or subtopic, I would say a flow chart. Okay, so this is a consolidated flow chart of the entire classification of matter and also hierarchy of matter. Okay, if you understand this flow chart and if you acquire a grip over this, you will never again be confused between which are pure and which are impure substances, which are atoms and which are molecules. Is there a difference between a molecule and a compound? Are compounds molecules or not? Etc, etc. Those all confusing questions and all of that you will not have in your head anymore. But then for that, you need to understand this flowchart very, very clearly. Okay? And that can happen only when you do what? Make a note of it, right? So let's get started. But in case, hold on, in case you have missed out all my previous videos and this is just the first time that you're attending my class, no mind him, this is Dr. Nazma Sheikh, okay? And I teach you chemistry. So let's come back to the whiteboard. As said before, I'm going to help you understand the flowchart of classification of matter. You don't have this flowchart in your NCERT book, but then it's there in other books, okay? So we know the definition of matter. What's matter? What's the matter? Matter is something which has mass and occupies space, isn't it? So now this particular matter, there are so many forms around us. That's a big problem. Like what? The furniture that you see around you is matter. The water you drink, the air that we breathe. You are matter. I am matter. All living things are matter. Correct? We are all different forms. Like for example, water is fluid, it's liquid. And gas, air is in gaseous physical state. Others are in solid physical state. Correct? Some are having different color, different taste, different properties, etc, etc. In the first chapter when we discussed, we classified matter into solids, liquids and gases. We classified matter into solids, liquids and gases, and that is one type of classification. But in chapter number 2, when we spoke about purity in the last class, we are classifying matter on a different perspective. So now I'm consolidating all the classifications and writing this, okay? So we are talking about classification of matter. The entire matter that's there in universe can be classified in 2 ways. Make a note of this. Can be classified in 2 ways. Of which type 1 or first classification, I'm talking about classification. First classification is physical classification. What is that? Is physical classification. And the second one is chemical classification. Of course, the second one is chemical classification. What's physical and what's chemical classification now? Physical classification of matter is something which is done based on the physical properties. Like what? Like the volume, size, shape, etc, etc. And you know very well about this physical classification. I'll tell you soon. Physical classification says that matter can be classified into 5 states of matter. Yeah, this is about the first chapter. The first one is solid, followed by liquid, and then gas. Can you tell me what are the rest 2 physical states of matter? The fourth one is plasma. The fifth one is BEC, Bose-Einstein condensate. Correct? So this is what? This is physical classification of matter. Okay, and this happened based on the physical properties of matter. You remember how did we differentiate solids and liquids? Solids are having fixed size, shape and volume, but liquids do not have fixed size, isn't it? And they don't even have shape. That's what we discussed about in the first 5 videos of chapter number 1. Correct? Similarly, gases and liquids, how did you differentiate? Liquids have fixed volume, but gases do not have. Correct? You classified all of them based on physical properties. So this is physical classification. And now this chemical classification of matter. Let me move the video. Yeah. This chemical classification of matter. This classifies matter based on chemical composition. I told you this in the last video, the just immediate last video. This happens based on chemical composition. Okay. So based on chemical composition, matter can be classified into two types, of which one is pure substance, other one is impure substance. Okay, so what is pure and what is impure substance? Pure substance is anything which is made up of similar type of molecules. You remember last class, purity is always spoken at molecular level. If you have a sample which is consisting of all same type of molecules, call it pure. It is pure. If you have a sample which is having different types of molecules, more than one type is impure. For example, I'll also show you one image just to make you understand more clearly. You just look at this image. Yeah. First one is tap water. Observe what is there in tap water. All colorful molecules, right? Say blue molecules are waters, yellow ones are maybe chlorine atoms, and the red ones are fluorine atoms, etc. etc. Tap water is a mixture of water molecules and minerals. When you remove all these minerals, you call it as distilled water. I said 100% pure water this is. You should not drink 100% pure water because it is corrosive. It dissolves the mucus lining of your food pipe. Remember? So 100% pure water is this. Look at the composition. It has all blue molecules only. All one type of molecules. That's when we call it as pure. What if it has different types of molecules? Then it is impure. But also remember, being impure is not being harmful always. Impure could be harmful, could be harmless also. Okay, let's move on. So pure substances are the ones which contain what? Are the ones which contain similar type of molecules. But there are two types of pure substances further, of which one is element. It's a molecule which contains. Are you making note of definitions? I'm not writing every definition here, but are you noting it down? Only having this is not helpful. Note down the definitions. That's when it is helpful. Okay? Write down. Element. Elements are the molecules which are containing same type of atoms like H2, N2, O2, etc. etc. Okay? And the second one is compound. What's compound? Compound is also a molecule. Okay. Is this pure? Yes, it is pure. That's what we are classifying, right? Compounds are pure substances. Okay, so compounds which are pure substances are the molecules which contain dissimilar type of atoms. Like what? Examples? H2O, CO2, CaCO3. These all are what? These all are compounds. Are these all pure? Yeah, they are pure. Because you're talking about one type of molecule, right? Yes, that's pure. Okay. Now these impure substances, I think it will be very congested here. What I'll do is I'll take you to the next page and I'll write this classification, chemical classification again here. Okay, so that you will not get confused or things do not look messed up. Pure we spoke about, and now it's about impure. Okay, I'll keep the video here. So now impure substances are what? By definition, what are impure substances? Make a note of it. Impure substances are the ones which contain more than one type of molecule in a sample. For example, if you, okay, I don't need to draw, I have an image. Look at this tap water, all different colored molecules in one sample. So this is impure. But you tell me, being impure, is it always harmful? No. Impurity need not be harmful always. In real life, we have misused the term purity and impurity. Okay? So now coming back, yes, this impure substances, most important thing. Impure substances are also called as mixtures. Okay? Impure substances are also called as mixtures. So these mixtures are of two types. Before I could tell you those two types of mixtures, I want to show you one other image. Okay? You take a look at this image. Forget about the terms, words and all of that. Just look at the image. Okay. So in this image, see what do you have? You have the blue and pink molecules. Second image, blue and pink molecules. Now closely observe these two images and tell me, is there a difference between both of them? Closely observe with regard to everything. The size, shape, arrangement, color of the particles that you see. There is a difference, right? What is the difference? Color is same, shape is same, size is also same. Then the difference is the positions of the the pink and blue particles. In the first image, the blue particles are at the bottom, pink are at the top. Okay. In the second, they are all arranged uniformly, alternatively. So what? Okay, so what means, I'll tell you, wait. In the same way, imagine that this blue colored particles is sugar and pink is milk. You added a spoon of sugar to milk, you did not mix, you just added. And you drank off the milk. Do you taste that sweetness in the top layers of the milk? No. So, of course, it makes a point being distributed equally, being uniformly distributed, or being just two parts, right? So, now you observe once more and tell me, are these two pure substances or impure substances? They are impure substances only. Why are they impure? They are impure because they have two types of particles in one container, right? So what is the definition of impurity? Presence of two types of samples or more than two types of molecules in the given sample. So these two are impure. But then in this impurity also, in the first case, they are not mixed equally. They don't have unity. Yeah, they're diverse. But then in case of second example, second image, you are having the particles arranged alternatively. Like you added sugar to milk, you stirred it well. Now you drink milk, maybe from the top layer, from the bottom layer, it is sweet enough, right? So now let's go back to the flowchart. These impure substances or mixtures are classified further into two types. Based on what? Always when there is a classification, you have to ask, what is the basis of this classification? You're classifying, fine. Based on which point is this classification happening? If you're clear with respect to that concept, done. You will get a nice grip over the subject. Okay, coming back. So now mixtures are classified into two types based on their distribution. What's distribution now? How well are they mixed up with each other? That's it. Simple. If in case they are mixed up with each other equally, alternatively, as shown in the second image, you take sugar, put it in milk and mix it well. Taste any corner of that milk, a drop of milk from any corner throughout the volume, you have the same sweetness, right? Try it if you want. And such mixtures are called as what? Homo. Homo in the sense equal or similar, okay? Or uniform also is fine. Homogeneous mixtures. What's genus? Genus is mixed up, equally mixed up. The mixtures in which, write down, the mixtures in which all the particles are equally or uniformly distributed, you call those mixtures as homogeneous mixtures. And homogeneous mixtures are the ones in which you have that uniform distribution, correct? Examples, say you have a spoon of salt mixed in a glass of water. You have put it into glass and you stirred it. Important, you mixed it. Then, after mixing, taste the water from any corner throughout the volume of the glass. You will have the same saltness, correct? Similarly, sugar water is uniform mixture, correct? So, the uniform mixture is something which has equal distribution. Done? What is the second type of mixture then? Opposite of uniform. Like what? Like you have taken a spoon of sand this time. Okay, spoon of sand. Put it into water. You stir if you want for half an hour, 1 hour, 2 hours. Thereby, see what happens. What do you think happens? Will sand get mixed up equally like sugar or salt? It will settle down at the bottom of the container. You mix it for 1 day, 2 days, 3 days, same case, it doesn't dissolve. It settles down at the bottom. Okay. Now you are having that sand water, but sand is at the bottom and water is making the top layer. Is this a mixture? Can this be considered as a mixture? Yes, of course. Why? You have one container which is containing two different types of substances, two different types of molecules. So it's a mixture. But the difference is it's not equally distributed. Such mixtures are called as heterogeneous mixtures. What are they called as? They are called as heterogeneous mixtures. What's hetero? Ununiformly distributed, unequal distribution. So now let's come back to the entire flowchart and see. Okay, I'm talking about classification of matter. Matter is classified based on physical properties, based on chemical properties. Physical classification says matter is of 5 types, solid, liquid, gas and all of that. That we completed in chapter number 1 already. Chemical classification is all about chapter number 2, which says that matter can be classified into 2 types based on its chemical composition. One is pure, which has similar types of molecules. Other one is impure, which is also called as mixtures, which has dissimilar type of molecules. I repeat, molecules. Underline that word. Okay. Pure substances are further classified into two types, elements and compounds. Both are pure, both are molecules. Composition of the molecules is different, that's it. Now, impure substances are also classified into two types, homogeneous and heterogeneous. Homogeneous means something which has equal distribution of all the molecules. Heterogeneous is something which has unequal distribution of all the molecules. Okay, clear? But now it's not yet done. We have one more step of classification. These homogeneous mixtures, they have another word. We can also call them as solutions. The most popular term and the word, it's the most popular topic in the entire chemistry. When you go to class 12, there is one chapter called solutions. Chapter number 2 it is. It's that important. So homogeneous mixtures are also called as solutions. Okay, but then don't mistake it. Solution need not be liquid always. It can be a mixture of two solids, two liquids, two gases, or mix of both physical states. Anything works. Okay. Now heterogeneous mixtures, is there any other name for them? No, there is no other name, but there are two types of heterogeneous mixtures. Okay, what are those two types of heterogeneous mixtures? First of all, based on what are they classified? They are classified based on the size of the particles involved in this mixture. If the size of the particles is like medium, then you call it as colloid. It's not collide, it's colloid. Okay. Collision is different, right? Collision is this. Correct? This is entirely different from that. Now the other type of heterogeneous mixture in which you have the particle size to be bigger or considerate. Such mixtures are called as such mixtures are called as suspensions. What do we call them as? Suspensions. So to summarize, heterogeneous mixtures are the mixtures in which you do have ununiform mixture or maybe unequal composition. The molecules are not equally distributed. They are some at the bottom, some at the top, some in the middle, some in the corner kind of thing. Okay, they don't have equal or uniform distribution. Now these heterogeneous mixtures can be further classified into two types based on the particle size. If they are having smaller particles or medium, you call them as colloids. If they are having bigger particles, you call it as suspension. How big, how small? We have the measurements. We have the measurements in terms of centimeters, meters and nanometers. But you relax, we are not doing it today. The next class, the next video in fact, that's going to be an important topic. Okay? Important than this. This gets you clarity. But that's a part of your syllabus. You'll get questions from there. Okay? We are going to understand the actual differences between a solution, colloid and suspension. Rather, I can say that you're going to compare and study these three things. What is a suspension? What is the particle size? Similarly, what's a colloid? What is the particle size? What is a solution? What is the particle size? Moreover, what are the examples of these three things? What other properties do they exhibit? Can we separate them? Are they stable? Etc. etc. We understand these three things in many dimensions in the next video. Okay, then what did we do today? Today we have understood the entire classification of matter, and rather than physical classification, focus more on chemical classification, because physical classification concerned with chapter number 1, which we finished already. Correct? We studied too much about the solids, liquids and all of that. Chapter number 2 is related to the chemical classification of matter, that impure mixtures, homogeneous mixtures, heterogeneous, solutions, colloids, suspensions, examples, how do you separate them, properties, so much. Okay, so this is about today's class. I hope this helps you to acquire clarity over the terminology and also over the content of these two chapters. Don't think this is out of syllabus. No, this is not out of syllabus. This is just a short version made by me to make things more clearer to you. That's it. Okay, but this flowchart is related to first two chapters of your syllabus. From there you can understand how important is this. Correct? Now let us wind up for today. I'll see you in the next video with a comparative study of these all three impure mixtures, which is going to be important. Don't miss it out. Okay? And in case you have some suggestions of the topics that you want to learn something, don't hesitate letting me know in the comment section. Done? I hope you are understanding these classes. I hope you're getting benefited out of these classes. And hoping so, I'll see you soon. Bye bye everyone.